Yay. Thank you so much, everyone, being here. Can you hear me okay? Cool. Yeah, so hope you're in the right place. We're going to learn about LangChain and RAG today. How many of you have used LangChain? Wow, a lot of you, so you don't need to be here. But, but I will try to be useful. Yeah, so before we get into our talk, let me introduce a little bit about myself. My name is Sophia Young. My background is in psychology, statistics, and computer science. I have worked at Anaconda for more than 5 years now. I contribute to open source packages, Python community, and Python ecosystems. I also have a book club. If you're interested, please consider joining. And so agenda for today, we're going to cover a lot of details today. Hopefully it's okay. We're going to talk about LangChain first, starting from the very basics. And then we're going to talk about RAG. And then finally, we're going to talk about how to build a chatbot with an open source package called Panel as the UI for the chatbot. So let's get started with LangChain. Oh, before that, if you want to see my slides, you can follow this URL or scan this code here. And then, okay, for people who are taking pictures. Okay, cool. And then all the code that I'm going to go through today will be on this link right here. Okay, so what is LangChain? LangChain is a framework for helping us develop applications powered by language models. It is context-aware, and it provides a way to reason about what actions to take. So we'll explain a little bit about what does it mean by context-aware in the following slides. But basically, you can have your large language models to interact with what is available for you as tools or other language models. You can interact with the environment and other sources, and think about like what tools to use, what actions, sequences of actions to take in your applications. So this is a workflow of using large language model that you might be familiar with. We have a user query, user asks a question, which get it feed into a prompt, and then the large language model get this prompt and then generate an output for us. So we're all familiar with this. What LangChain does is LangChain provides many different components in this workflow to enrich this experience. The first component is LLMs. LangChain provides a consistent interface to work with many different model providers, because it's not just OpenAI on here. There's a lot of models on Hugging Face. There's local models like Llama 2, Mistral 7B, and others. So you can use all those models with LangChain. So here's a very simple code snippet to just show you. Basically, you can import different models. It's a wrapper around different model APIs, and you can use different models with LangChain. So, for example, I loaded ChatGPT, GPT-3, Cohere, and Bloom models, and I asked how to be happy for each of the models, and you can kind of compare and see which model give you good answers. Like all of them pretty much give us good answers, except for Bloom. I'm not going to go quickly because, yeah, Bloom basically didn't give us good answers. But here's an idea for you to try. You can see different models with LangChain pretty easily. Another important component is prompt template. So I like to use prompt template when I work with local models. Here's an example where I am using, does it do pointing? Oh, cool. When I'm loading a Mistral 7B model, and different local models have different format. For example, this is the format that Mistral 7B uses, right? And then I only want users to change the user input every time they interact with the Mistral model. So the user input here, you can see it looks basically just like a F string in Python. And then we can ask the question, how to be happy with the Mr. model directly, where you don't need to use those formats for every time when you interact with your models. So that's prompt template. Another component is output parser. So a lot of times when we work with our language model, we want our output to be a certain way. Like for example, here we use a Python Pydantic parser, and we want it to, the output looks like this, an actor class with the actor name and the films, right? And we ask the question, answer the user query, what's the question? Generate the filmography for a random actor, and it was able to give us this really nice looking structure of the output data. The actor is Tom Hanks, and the film names are the list of film names. So this way, the unstructured data will be structured into the structured data for us to use very conveniently later on. Another important component is memories. Because a lot of times when we work with OpenAI APIs, it doesn't really keep the previous memory for us. But if you work with ChatGPT on the UI, it does keep the memory, but when you work with the APIs, it usually doesn't. And LangChain provides many different memory methods for you to choose from. For example, here we can use a conversation buffering window memory to keep the last K interactions. We can keep the last 1 interactions in the memory. And then later on, we're going to send this 1 interaction to the prompt for the next interaction. And then we can also use a conversation buffering summary memory to summarize the conversation over time. If you want to combine different memory modules, you could combine those 2 memories together. And then to show you an example, here we just ask the language model, hi, and then you can see the summary of the conversation is empty, and the current conversation is just hi, and the large language model answers, hi there, how can I help you? Right, and then I ask it, can you tell me a joke? Now the summary becomes the human grades the AI, to which the AI responds and offers to help. And now we can see the current conversation updated, and the AI give us a joke. Sure, what did the fish say when it hits the wall? Human said, I don't know, AI said, damn. Okay, I need some water. Okay, and now, come back. And now we ask you, then we ask, can you tell me a similar joke? You can see the summary of the conversation updated, right? With the context that human asked the AI to tell a joke, to which the AI responds with a pun about a fish hitting a wall. So with this context, the AI was able to give us a very similar joke. I hope this can help you see how you can use different memory modules to input different memories into your language model. The next important module, or one of the most important component in LangChain is probably chains. With LangChain, we can chain different large language models together and chain different components together. So here's what I mean by that. Here's an example where we start with a LLM chain, which we ask, what is a good name for a company that makes a certain product? So we want to input this product, right? So our first chain is basically just chaining the prompt template with our large language model. We use this LLM chain. So another way to write this is to use the vertical bar. It's called the expression language to do the prompt vertical bar and the LLM. It's the same thing. Expression language is LangChain's new way of expressing the chains more easily. And then in the next chain, we have write a catchphrase for the following company, which inputs a company name. So when we run those two chain together, what happens? So we input colorful socks as the name of the product, right? We want the first chain to input the name for the product, and then use that name as the input as the second chain. So that's exactly what happens, right? When you use a simple sequential chain, you take the output of the first chain as the input of the second chain. So the first chain gives us the company name, Rainbow Socks Inc. The second chain gives us the catchphrase, put a little color in your step with rainbow socks. So so that's basically how you can chain different large language models together. But this is like super flexible. You can even use two large language models to output something, combine them together, and feed them into the third chain. Or however you like, you can customize how you want your logic to work together. And another important component of LangChain is tools, because without tools, it's the power of large language models is quite limited. Because if you want to work with Google search to keep up to date with the current information, right, you might want to ask a large language model to perform a Google search and get the information. Or if you want to run Python code, you can use a Python wrapper tool or a calculator or many other tools that Python provides. Here's an example of a tool where we have a SERP API wrapper. Wraps around SERP API, which is a Google search API. And we can run a search query and get answers from Google search. So if you look at the utilities directory in LangChain, each of those wrapper file is actually a standalone Python file. Some of them are like really simple, just a few lines of code wraps another API. You can write your own Python file to wrap an API, or you can just take that out for your own use cases, even if you don't use LangChain. Okay, but with so many tools, how do large language models choose which tools to use, right? So the concept of agent is to help you choose a sequences of actions to take. It sounds very vague. It's actually not that complicated. It's just prompt engineering. Or just to help you choose which tools to use. Here's an example. We have two tools here. We use the SERP API, which is the Google search, and we have a math calculation tool. And then we, again, loaded our language model. Here is the magic happens. We need to define an agent type. There's many agent types. We use the zero-shot React agent. I'll show you the prompt in a second, and you will understand what does React mean. It's using the React framework for prompting. So in this example, we ask, who is Leo DiCapricio's girlfriend? What is her current age raised to the 0.43 power? The language model was like, I need to find out who Leo DiCapricio's girlfriend is, and then find her age and calculate it raised to the 0.43 power. It was able to recognize the action to take right now is to do a search. And the search input is Leo DiCapricio's girlfriend. Now we get the observation, right? And find the name of the girlfriend, right? This is actually, I don't think this is correct information. But anyways, it was able to find it somewhere on Google search. And then the thought is, I need to find this person's age, Kamina Moron's age. And then we know the action again is doing another search. Sorry, more water. Right, and then do another search, find the age is 25, and then thoughts again, we need to calculate this calculation, and the action is to use a calculator to do the calculation. As you can see, it's the thinking and the observation comes like repeatedly, step by step, to use the search tool and then to use the calculations. So this is a prompt for this query, basically. And also this is what the React framework is. We give the description of different tools. The search tool, this is a description for the search, description for the calculator. And then you need to use the following format. We have question, input question you must answer, the thought, you should always think about what to do, action, what actions you want to take, action input, which is the input to the action, and the observation, the result of the action. And you can repeat this process many, many times until you get the final answer. So this is basically what agent is doing. As you can see, it's very straightforward prompt engineering stuff. And of course, there are many other types of agent. And if you're using OpenAI APIs, you should consider using the function calling API instead of this generic agent. But this would work for other models if you're not using OpenAI. Okay, so that's LangChain. I want to, I hope that's give you a good basic understanding of LangChain. I hope now I'm just going to gear a little bit to RAG, because a lot of times we want to do something different. We want to chat with our data or our knowledge base. If you have a company, where did it go? Yeah, so if you want to chat with your company wiki, if you want to have some context about your query, and this is a great way for you to understand your context and give that context to your large language model to be able to answer things more correctly. It's a way to reduce hallucination, but it doesn't actually reduce everything, 100% hallucination. So at a high level, when users ask a question about your knowledge base, for example, if you're looking at a PDF file about Llama 2, right? You can ask the ins and outs about Llama 2, and your knowledge base will be that. Oh, thank you. Will be the PDF file you're reading. And we can use a retriever to retrieve the relevant text chunks that your users is asking, right? We compare this user query with your knowledge base and find what are the relevant text chunks. And we append the relevant text chunks in this user query as the prompt feeding to your large language model. So now the large language model have both the question and the relevant text chunks as the background knowledge and was able to answer your question more correctly. Here's a closer look. Think about your knowledge base, your data source as anything you want it to be. It could be GitHub, it could be Twitter, it could be any types of documents. We use a document loader to load your document in a semi-structured, unstructured way. And then we need to transform your text file into, basically break it down into different chunks. We use a text embedding to embed your text chunks into embedding vectors. And then we store them into a vector database. So why do we need to do this? Because when we have a question, when we want to retrieve which text chunks are relevant, we have a query embedding vectors somewhere, and we want to do a similarity search with all those text embeddings. You can just do a dot product for a similarity search or some more complicated search schemas, and then you can retrieve that text embeddings for you. Is it clear? Any questions? Okay. So to quickly take a look at the code, right? Here I have a PDF file, examples.pdf. I use the PyPF loader to load this PDF file. And then I used a character text splitter to split my document into chunks. Some people say the smaller your retrieved chunks are, the better, because it's easier for the vector database to do the similarity search. but that's another topic later. And then you need to choose what embeddings you want to use. You can use a OpenAI embeddings, or you can use any embedding models from Hugging Face. And then we create a vector store to store those embeddings. And then finally, we define a retriever to tell us, okay, I want to do a similarity search. And then I want to search the top K most relevant text chunks from any document, from this document, right? And then I create a retrieval chain to answer my question. This chain basically chains the large language model and the retriever together to perform this operation. And then we ask the question, how many AI publications in 2021 from this document that I found on Stanford website? And it was able to answer, give me some answers. If you want to see what documents are returned exactly, you can define return documents equals true, and it will give you not only the answer, but the 2 relevant text chunks it was retrieving, and this is what get fed into the large language model to answer the question. So the steps are quite straightforward, as you see, but every step can be optimized. I'm not going to go deep into this, but just to give you a few examples as a few flavor for you. So for example, things in the middle get lost. So if you want to retrieve a bunch of relevant information and your important things are in the middle, then you're in the trouble because your large language model can't really find that information in the middle. So you might want to consider, where'd it go? You might want to consider reorder your document to have the important bits in the beginning or in the end. And also, a lot of times we don't need to do semantic search all the time, right? Sometimes because we have a database which has filters, which has metadata, we want to do a combination of semantic search and metadata extraction, metadata filters. So we want our retriever somehow to generate that filter for us to, like, for example, generate the filter author equals foo in this case, author equals bar in this case as a filter instead of passing this as semantic search, right? If this is in your database as a column, as a metadata, it might perform better performance if you just do the filtering on the column. And another example you mentioned is a lot of people are trying to improve RAG by fine-tuning your RAG. Right? It's called Retrieval Augmented Instruction Tuning, meaning that you want to append your retrieved document as input in your fine-tuning process so that your model can take more information, a better use of the relevant information, but also ignore the irrelevant information, because some of the information you have in your input data is irrelevant. Okay, so yeah, that's probably another talk to talk about how to optimize, but just give you some ideas of things you could look for. And finally, the final section of this talk, I'm going to talk about how to build a chatbot using Panel, just to put everything together, give you a nice looking UI for this. So Panel is a dashboarding tool in the HoloViz ecosystem. The HoloViz ecosystem has 8 tools. It's popular for data scientists and scientists to do Python visualization. Again, this is open source. It's supported by Anaconda, but it's completely 100% open source tools. You can do big data visualization, streaming data visualization, and also building dashboard using HoloViz ecosystem. And Panel is the system for building dashboard. So, okay. Could you click the GIF, please? Yeah, okay, cool. So, I guess not much information. But here is a basic UI that you can make in a few lines of code. So what does it do? The user says hi, the system just echoes the user hi. There's nothing AI here yet, right? So how to do this? This is 8 lines of code, right? We import panel, and we define a callback function. You can see basically just printing this message, echoing user's content. The secret is in this panel chat interface method, where it defines all of this layout and every functionalities that you don't need to define. And in the callback function, we just need to call back how the system should respond to the user. So that's basically it. Very simple. And then to build a chatbot using OpenAI API, right? So you might look familiar here. We have the large language model. We have the memory module here. We have a chain, right? And now in the callback function, we just use chain predict, which is the async version of the LangChain, and then ask the language model to give us the output based on the user input. And again, in the chat interface, we define this callback function. And could you click the GIF, please? Okay, cool. And now we can have a conversation with LangChain, which is powered by GPT 3.5 Turbo that we defined in the LLM. And it actually has a memory because, we asked add 1 to the previous result, and it was able to have the information about the previous result and give us the answer. And then finally, this is chatting with your PDF. Could you click? Yeah, thank you. So here we can upload a PDF file, send into this UI, ask questions, any questions you want with this PDF, right? And it will return the answer and also 2 relevant sources because we defined number of relevant text chunks is 2 here. And here is where you input the OpenAI API key and chain types that I'm not covering right now. So making this is also quite straightforward. You first need to define the widgets you are interacting with, right? You need a widget to input your PDF file. You need a widget for typing your OpenAI API key, a widget for choosing number of relevant chunks, a widget for choosing the chain types, right? It's all really easy using the panel widget methods. And then step 2 is to wrap this LangChain logic into a function. By the way, so all the code you can find on this link here. You can wrap the LangChain logic into a function. So we have seen all those code before, you're probably familiar with. We just define a function of it. The only thing different is we replace some of the values with the widgets we just defined, so we can control those widgets. Instead of using a set value of like 2 relevant chunks, we now can, using the sliding function widget to choose number of relevant chunks. And then step 3 is to create a chat interface. The key ideas here is everything that's showing in the UI need to be a panel object. It cannot just be anything. And then step 2 is to customize the look with the template. There are so many different templates you can use, which will make your app look a little better. And now you can have a final UI that's an application you can share with other people and other people can use. I know we are probably very out of time. Oh, cool. We have 30 seconds left. Cool. So that's it for this talk. I know it's a lot of information. Thank you so much for being here. Thank you.